Okay, so today we are going to start with recursion. And a definition for recursion is this. Take a picture, and then print it, hold it, take another picture, print it, hold it, another picture, another picture. This is exactly what we mean by recursion, which is using the same thing many times, right? So for example, I have a function, I'm calling it from the main function, right? So user-defined function, calling it, okay? Then, based on this picture, the function will call itself as many times as the function needs, right? And then finally, at some point, something will stop this recursion process and I will get the output, or the return statement to the main function, okay? So mainly, when we are dealing with recursion, it's a function calling itself, okay? A function calling itself. Is it clear? The main concept. It's exactly the same here. This guy taking the picture, printing it, holding it, taking a picture, printing it, holding it, taking a picture, until a certain point, he will stop, right? And the same thing. Me, as a user-defined function, I will call myself Muhammad, 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 with different input. Let's say I will call myself with Muhammad 5, and next time I'll call myself Muhammad 4, Muhammad 3, and then I will put a condition. If the number, the input to this function is 1, return 1, for example. So I will stop at a certain point, right? I will continue calling myself until stopping at a certain point, and that's it, okay? So this is what we mean by recursion. So I think this is exactly what we are going to do. Going to a depth with calling just the function. Until a certain point, you have to stop. Okay, so an example for that, you can just see the definition. When you are using somehow what we want to define it. So for example here, debugger is a tool that is used for debugging. Can you see that? I'm using the same name for just defining it, which somehow weird, but this is what we are doing in recursion, right? We are using the function to call itself, right? So here, debugger, it's somehow something dealing with debugging. So again, I don't know, right? But this is how we call the recursion process. Okay, so mainly when you are dealing with the recursion function, the main objective there is to implement a certain, say, user-defined function. And if you are dealing with recursion, you can do the same thing with iteration. Because iteration, you have, like, let's say, a for loop, right? Or while loop, and then you are trying to do iterations until a certain condition. Let's say I want to iterate for 10 times, right? So this is the regular iteration. The same thing you are going to do with iteration is exactly can be achieved by recursion. And we will see example for doing this in iteration, doing this in recursion, and we'll see what the difference actually and which is better to do during your programming. So this is how you can finally look at your problem. If you have a very small problem, okay, you don't have to use recursion because you will have 2 or 3 lines of code and then that's it. You solved the problem, right? But if the problem is large enough, we will just try to take the problem and partition the problem into small problems and try to have the user-defined function to solve this small problem and then recall itself to do it and to just solve the big problem, okay? So, for example, here we have a list of numbers, okay? 24, 88, 40, and then 37. And we will try to have a definition, which is a list is a number, okay? Or it is the number, comma, list. What's the meaning of that? The meaning actually is looking at this here, okay? I will say, since I'm having more than one number, because I have here 2 definitions, right? One definition if you have a list which is having only one number, and the other definition is a list which is having more than one number, right? So what you can say here is that a list is 24, comma, list. Again, we are using the same definition to define again, right? So here, a list is a number, comma, list, right? And this is what we mean by recursion. So if you want to do this, you will start here. A list is 24, comma, list, right? And then the second list, you want to define it. How you are going to define it? A list is a number, which is 88, comma, list, right? And then you have to continue because I didn't achieve the last condition here, which is a list is a number, having only one number remaining in the list, right? So I'm going to continue. A list is 40, comma, list, right? And finally, the last definition will be 37 and don't have any new lists, right? So I don't have to go again and define the list. I'm having a condition which is terminating, right? Because in the definition, I have two things, right? The first thing, a list is a number. It's applicable here only, right? And then a list is a number, comma, list. It's applicable in the first case, second case, third case, right? And this is how we are doing the recursion. Here, I'm calling myself again to define the list, right? Or the second list. Calling myself again to define the third list. Calling myself again until going to what we call a base case, that you don't have to do the recursion process again, right? And at this point, you have a number, a number, a number, a number, and finally, I got what I want, okay? Is it clear? Okay, we are going one by one, so let's continue with that. One very important thing you have to make sure that you are implementing with recursion is that you have to have a base case. What the meaning of base case? If I'm just going to call myself, okay, without having something to stop me, I will call myself forever, right? Right? So every time you are writing a recursion function, you have to make sure that you are getting a base case which will stop the recursion process at a certain time. Okay? So calling yourself until a certain condition, which in the last example, the certain condition is having two definitions for a list, right? One of them, a list is a number, and that's it. And this is applicable when I have only one number in the list, right? And this is my base case. So every time you are writing a recursive function, the first question you have to ask yourself, what is or are my recursive or base cases or case? Okay? So what will stop this recursion process? Okay? This is a very important question when writing any recursive function. Okay, so let's now have an example. So we want to play with factorial n. Okay? We want to write a recursive function to find the value for any factorial. So I will have a function which is trying to find factorial. Let's say factorial 5, right? So factorial 5 is 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1, right? Okay, so how we are going to think about this? The first thing, what is my base case? If 1 is stop, right? Agree? Okay? So every time, whatever the number you are trying to find the factorial, 1,000, you will start with 1,000, multiply 999, multiply 998, and so on. But finally, going to 1, you have to stop, right? So here, when you are trying to write a recursive function for factorial, you will have the first thing. If the number equals 1, stop. Or stop here means return 1, right? Because factorial 1 is 1, right? So in this case, I will return 1. Okay, this is the base case. How you are going to call yourself? Yes. So actually, when you look at the factorial, let's say 5 again. So 5 multiplied by 4 multiplied by 3, 2, 1, right? Everyone can see this? Okay. So this is factorial 5, right? Also factorial 5 equals to 5 multiplied by factorial 4, right? So in this case, I can say, hey, if you want to find factorial 5, I will start with the base case. If the number is 1, return 1. Else, return 5 multiplied by factorial 4, right? And then the next time I'm calling myself, is the number is 1? No, still. Okay, the factorial actually, or you have to return 4 multiplied by factorial 3. call the function again with input 3. Again, right? So you have, while thinking about how I'm going to write this function, you have to write something like this. Base case, right? So let me just write here. This is base case, okay? And then how the recursive process is going to happen, right? So once you determine both of these, it's now very easy to write a recursive function for factorial, right? Because now you understand everything. Here's my base case. Here's how I'm going to have the recall of the same function, and that's it, okay? So finally, when you write something like this, you'll find that you are having this, right? Which is 5 or factorial 5, and then it is the same as 5 multiplied by factorial 4. It's the same as 4 multiplied by factorial 3, and so on until going to 1, right? And when you are dealing with recursion, you will find that the function here is calling this function. This calling this. This calling this. And until now, I didn't get a final solution, right? I'm calling, just calling, continue call, until getting a number. Okay, now I have to somehow return back and calculate, right? Once you got 1 here, 1 multiplied by 2, 2. 2 here, multiplied by 3, 6, and so on, right? So in the recursive functions, you are going in this way to call all possible functions until the base case. Get a number from there and return back to calculate what you need. Can you see how it is going? First direction is just to find what is the end of this call, right? I'm calling. Where's the end? Finally, going to the base case, you will get a number from there, and then return to substitute, and returning back to get the final answer, which is here 120. Okay? Any question until now? Okay, so before writing the function itself, which is the recursive function for finding the factorial, let's try first to write the factorial in iterative way. Okay, so anyone having an idea how we can write factorial in an iterative way? Yes.
You could use a for loop and go from n to 1.
Uh-huh.
And then have a variable outside of it for your
Product, for example. Okay.
Just multiply it by I as you get there.
Perfect. Yes.
You could have the number like you could have it take one integer and then subtract that integer and then call it again with the new integer and then once you
And then every time multiply, right?
yes.
Perfect. Very good. So here's mainly both of you are actually right. So you will have here something like this. So here's the function, user-defined function. And the input here is the number that I want to find the factorial for it. And after that, I will have here initialization for result equals to 1. And make sure that here is 1, not 0, because you are multiplying. Okay. And then for I equals to 1, I less than or equals to a, which this is the factorial, right? If factorial 5, I just want to go until 5, right? And then I plus plus, and then result equals to result multiplied by I, or result multiply equals to I, right? And finally, return result. So now I'm getting the factorial, right? But using iteration. So, excuse me. So now let's try to do it using recursion. So again, we will call a function. Let's say we will name it the same name, factorial. Okay, anyone can tell me how we can at least start?
The base case.
Base case, right? So the first thing, I will start with my base case, which is f right? Then what you have to do? Return 1. Okay, else?
Return a times factorial recursive of a minus 1.
return a multiplied by factorial underscore recursive a minus 1. And then closing this and closing this, right? Let's see again. Base case, if a equals to 1, this means that factorial 1 equals to 1, I will just return 1, right? Else, directly return a multiplied by factorial n minus 1. So let's say the number here is 5. You will start here 5, check, no. Else, a, which is 5 multiplied by factorial of 4, right? And then you will go back 4, and then you will have return 4 multiplied by factorial of 3. 3, return 3 multiplied by factorial of 2, and so on, right? And again, as I said, every time you are going this way, you're not calculating. You still don't have numbers. Every time you are calling a new function, right? Once you are at the base case, you have to return to the other way. This is why in the exam, for me, to test your understanding recursion or no, I'm actually asking you to find the output than to write recursive function. Writing recursive function is very easy, easier than iteration. If you look at the program we just wrote now and this one, you'll find that somehow writing a recursive function, if you understood this part, how you can get the recursive process, and it's very easy to write it. Okay? So mainly, when I'm asking you, I will just try to find, did you understand or no? So in this case, okay, go and find the value. What's the return, finally, the final return from this function, recursive function, okay? We will have a lot of examples, and mostly this week and the week after Thanksgiving break, we are going just to work on recursion to make sure that everyone is understanding what's happening with recursion. Okay, so this is how things are happening. The only difference is that we are continuing here to 0, which again, when you are finding the factorial of 0 is 1, right? So instead of having base case 1, you will have here the base case is factorial of 0, okay? And you will have the same result exactly. You don't have anything different, or the number is different or anything. The only thing here, we are finding factorial of 6. Okay. So as we learned, the main things here, the first thing is to find the base case. The second thing is to find the recursive case, right? Once you found both of them, it's very easy actually to write a recursive function. Okay, so let's see another example. So here we have consider the problem of computing the sum of all the numbers between 1 and any positive integer n, okay? This problem can recursively defined as, so here you have summation from I equals to 1 to n, right? Which equals to n plus summation from I equals to 1 to n minus 1, right? And again, until what is the base case? What's the base case in this case? What? When n is 1, zero. Who agrees with 1? Who agrees with 0? With both? Both will work. You can stop at 1 or stop at 0 because you are adding, right? So you can just stop after adding 1 or stop after adding 0, right? Because 0 added is not having anything, right? So this is the last thing. You will start with n capital, and then let's say n capital is 10, okay? So you have 10 plus summation of 9 numbers, right? Or 9. And then plus 9 summation 8, plus 8 summation 7, right? What is the last thing you have to go? When you have calling the function, which is summation 1. And this will return 1, and that's it, right? Or if you are going to play with 0, you will have calling the function which summation 1, and then the function summation 1 will be 1 plus calling the function which is summation 0. The function which called summation 0 is returning 0, right? So you can have it from this way or this way, okay? Just having one more step. So can we write this function with each other now? Let's start by saying int sum int a, okay? And you want to store the result, right? So we'll have a variable here which is called int result, okay? And then what is the base case?
A is less than or equal to A. I mean, less than or equal to 1.
Okay, if a, right? Okay, it's the same, exactly the same.
Well, what if they pass 0?
Great, you're right. Thank you. So he raised a very, very important point, actually. For me, I said, okay, if a equals 1, right? And he said, if a less than or equal to 1, okay? And my claim is that while I'm going down, I will hit 1 first, right? But his claim is, what if the user already input 0? If I want to find factorial 0, right? So you are right, I'm wrong. So I will go with less than or equals to 1. But the problem here is that, what's the problem here?
You're going to return 1, but if you pass 0, it's going to be, you return 0.
So what if the user entered a negative number? So let's consider that the user can input only Boston numbers, okay? So user
Can you just fix out 2 base cases then?
no, you can just have, similar to what we did before, if like we are scanning from the user and then making sure in the main function that the user inputting a Boston number. If you didn't enter, I will put him in a while loop. Please enter Boston number, please enter Boston until he enters a Boston number, right? So we know that, right? If you want to enforce the user to do something, put him inside while one loop, for example, and then finally break if he did the right thing that you want, okay? Okay, so if a less than or equals to 1, what we have to do? Return 1. All agree? Okay, we are done here. And then, what's after that?
Return A plus sum of A minus 1.
Return a plus sum of a minus 1. I agree if we did that, so we don't need to have this. Okay? So in this case, I will return directly a plus sum of a minus 1. So again, if you have the number here is 10, so you will start with 10, just pass from here, go here, 10 plus sum 9, right? And then you will recall the function again, 9 plus some 8, and so on until going to 1, and then return back to substitute, substitute, substitute. Okay? Is it clear? Any question? Yes?
Is there like a scale in which recursion isn't good? Like let's say you're dealing with like a really large case, because it creates like a new environment every time, right?
Thank you very much. I was trying to keep this inside until maybe Thursday, but you bring it up, so let's say it. The problem with recursion is that every time you are calling a function, you are going to the memory, reserving for these variables, right? Call the function again. You will go to another place in the memory, reserve again for your variables. Call the memory, recall. You still, the other ones are still open, right? You still didn't finish with them. You are just calling a function, and then there is another call, so going to the next call, going to the next call. So every call, you are reserving in the memory a certain part, right? So this is why recursion is, I can say, like destroying the memory. So this is why if you are designing games, never use recursion. right? Because games already are memory consuming, right? So you are going to use recursion. At a certain point, you will find everything is stopping, right? Because you are already consuming in your main function good amount of the energy, and then after that, you are using a recursion function until this recursion function. Once this recursion function calculated whatever is going to calculate and return back to the main function, whatever it's going to return, everything will be deleted from the memory, and this will be good, right? But what if you are having a huge amount of call or many calls, right? So at this point, it will maybe go out of memory. Yes?
Is there that big of a difference, though, if both recursion and loops run with complexity of code and time?
So this is actually a trade-off. This is why every time you are going to use iteration, this is why here I'm going with showing you here's the iteration, here's the recursion. Because at a certain point, I may ask you, like recursion is better than iteration. No, it's not all the time. There's always a trade-off between this one and this one, right? Mainly if you are talking about recursion, it's consuming memory, right? So this is the main difference between them. Okay, any other question? Yes?
So like, what's the big upsides to recursion over iteration?
So it's very easy actually to write the recursive function. If you look, like here we have very, like let's say, toy examples, right? If you go to another example, which is somehow, it's not easy to write, you will find it's much easier to write it in recursion than write it in iterations. And we will see in the upcoming weeks, we will see something like this. A problem that I will ask, hey, let's write it in iteration and recursion. You'll find that the recursion is very easy. Iteration is very hard. Okay, so somehow it's easier to write a function in recursion. Any other question? Yes?
Could pointers be used to help with the memory issue?
Pointers, somehow you are going to have some problems. Why? Because now you are changing the variables in the main function, and this will play with, every time you have a new iteration, you are playing with the same variable, This is why we avoid pointers with recursion, because it will mess up everything. Because every call is changing the variable in the main function, right? Because you are directly there to the memory part and then change that. So every call is changing. So you may not be able to keep track of what is happening actually with the main variable that you are changing it, okay? Any other question? Okay. So we will see now an example for the same thing we did, like the addition. If you are having, let's say, 10, so 10 plus 9 and calling the function and so on. So in this one, we will just see an example, how the flow is going. So if you are calling the function, which is called sum, and you have just the input is 2, so in this case, you will call a function, which is called sum1, right? And then in sum1, it will just go and get the value, which will just return 1. We'll take the 1, return it back here, and then find the result, right? So it will have finally 2 plus 1, which will give the 3, and that's it. So this is a very basic example for calling the function which is called sum. If we call the same function with, let's say, 3, in this case, you are in the main function and calling sum3, you will just go to the function which is called sum3, right? And then inside this function, you will call another function which is called sum2. And then this function will call another function, sum1. And then finally, returning 1. When returning 1, you will go to the other side to find the values, right? So just make sure that you are looking at these two directions. This direction, base case, this direction, calculate the values, right? And as we said, in this function call, you are reserving in the memory for the variables of this function, right? In this function call, you are reserving the memory, and so on, right? Until return from here. Once you got this return, you will destroy everything here in the memory and free the memory, right? And then here, calculate and then destroy return finally to the main function. So all of these will be deleted from the memory, right? So somehow when you are going in this way, all of these are reserving in the memory locations, right? And then once you got this return, return here, delete, return here, delete, return to the main function, everything else is deleted in the memory, okay? Okay, so let's see another example here, which is the same thing. Hey, return back. Good. Wow. Okay, so this is the same thing, actually. So here's some 3, some 2, some 1, and then returning back with the values until calculating the value here, which is 6. Okay, so let's try to write this function, but this time using iteration. So, excuse me. So find sum, which is, let's say you have a number a or something, and you want to use it, but without using recursion. This time I want to do it using iteration. So how we can do it?
Have a sum variable.
Okay.
Write a for loop, adding from 0 to a to the sum variable.
Okay, so for and I equals 1. Starting from 0 will not do anything because you are adding 0, right? So it's better to just start with 1. You are just trying to make sure that you are efficient enough. You are not going a loop or one iteration which is useless, right? Which is not going to do anything. And at the same time, you will get the same answer. But at least try to be efficient from the number of loops you are going to have. So starting with I equals to 1, and then I less than or equals to a, and then I plus plus, and
Update your sum variable by just adding I.
okay, so result plus equals to I, and then here I want int result. This is one option. Another option is just return directly, right? So after finishing this loop, you will have return result, and that's it, right? So this is how we can write it using iteration. Again, just having the number that you want to add and finally adding it. So this is something we did a lot, right? Which is somehow easy to implement. Okay, so I think we already have this one. So today's application activity, it just, again, we don't have any application activity. It's going to be posted after the class, but this is the question. Find x to the power of n. In this case, if you have, if you have any number for x and n. So trying to have a recursive function to get this, right? So the question now is, what is the base case? What is the recursive case, right? So try to discuss very quick with your group and try to, at least in 1 minute or maximum 2 minutes, try to discuss and try to find how we can get it. Just to make it easier, try to assume that x is not 0 or 1. It can be any other number, okay? Okay, so what is the base case?
Base case is n equals 1.
No, it's n equals 0. If it's 0, you have to return 1.
Or you can just return
One by one. Wait, you are discussing with me, guys. Hey, I'm here. Okay, just wait. What's your answer?
if n equals 1.
If n equals to 1. What's your answer?
If it equals 0.
Okay, good. Other teams. We have debates now, so n equals 2? Yes. Let's keep this now. Okay. Let's keep this. We just starting, so we just need the regular way. Okay. Other groups. You didn't hear anything from the back. Base case. When n equals to 1. Okay. So what if n equals to 0? So let's take an example, okay? So let's try to calculate. Oops. Why? 2 to the power of 3, okay? So 2 to the power of 3, okay? I want to calculate that. So I can say 2 to the power of 3 is exactly the same as 2 to the power, 2 multiplied by 2 to the power of 2, right? And then I can say 2 to the power of 2 is 2 multiplied by 2 to the power of 1, right? Okay? And then 2 to the power of 1 is 2 to the power of 1 multiplied by, is 2 multiplied by 2 to the power of 0. And finally, when getting to the power of 0, it will just be 1, right? So the other way, whoever is saying 1, okay, I will stop the base case 1. So what's the justification here if I'm going to stop at base case 1? What you are going to return? We are going to return x. So both are right, here and there. So if you are going to stop here at this point, you have to return x itself, right? If you are going to stop here, you are going to return 1. Because 2 to the power of 0 is 1. Not 2. X to the power of 0, whatever, is going to be 1, right? So when dealing with recursion, there are a lot of solutions. It's not only one solution for it, right? It's based on what's your consideration on the base case, right? And making sure that with the toy example, that your logic is going right, okay? So here, my consideration, I just considered that I'm going to have x to the power of 0 equals to 1. This is my base case. And after that, I will just have this recursive case, which is x to the power of n equals to x multiplied by x to the power of n minus 1. And every time I will check if n equals to 0, I will just terminate or just have the base case and return 1. Okay? Okay, so you still please go to Canvas and discussion board and write your code there. Not now. Anytime it's open. There's no due date or anything, just for practice. Okay? So let's see this. So here, I want to find the length of a string. Okay? We did that a lot, right? Using string length or implementing the function which is called the string length, right? So here in this case, I want to find the length of a string using recursion. So again, let's have another 2 minutes, discuss that, and let's have another debates about it, and finally trying to get the right answer. So please start. Okay, base case. Null character. Everyone agree? Perfect. Okay, so I will stop when just I had the null character, right? I will just go over the string characters, and then once I find a null character, I will stop, right? So this is the base case. What is the recursive case?
Don't you have to pass in a counter of some sort, so that way you increment the counter and then check the character?
Are you going to do it using iteration?
No, just using a function that has a counter as one of its parameters, and then you just increment the counter each time and check it at the counter minus 1 at that null return count.
So where you are going to call the same function?
So say your function is called string length.
Okay.
And you're passing in the string, but you're also passing in your counter. So when you get past the base case, you return with the string and then increment your counter. And then so your base case is checking the counter.
Okay, but I think there is an easier answer for it. I think you are going in the right way, but I don't want to input another parameter with, my parameter. I just want to recall with the same parameter, and that's it, without any additional parameter. Any answer? There is, yep.
Well, if the first element in the string is found to be the null character, then you return 0. Otherwise, you would return 1 plus itself.
Perfect.
1 if the S is referring to the index of the next character, starting character.
Okay.
Basically, chop off the first one.
Let me show what you are saying here. So you will start here, okay? You will start with this, and then you are going to return 1 plus, right? And then return 1 plus E, and then return 1 plus, once you arrive to the null character, you are going to, this one is going to return 0, right? So in this case, once you have the null character, your return will be 0, and finally finding it, okay? So I'm going again to put on discussion board just another post for this one, okay? And I will wait for your input to write the program which is going to do this. So this is the idea. You have the idea. Just try to make sure you are writing a program. You can check it with any string and make sure that it's giving this string. Any question for me? Okay, thank you very much.